The Mars Orbiter mission, informally called Mangalyaan, is a Mars orbiter launched into Earth orbit on November 5, 2013 by the Indian Space Research Organisation. It is expected to enter orbit around Mars on September 24, 2014. The mission is a technology demonstrator project aiming to develop the technologies required for design, planning, management, and operations of an interplanetary mission. The Mars Orbiter mission probe lifted off from the first launch pad at Satish Dhawan Space Center SHAR, Sriharikota, Andhra Pradesh, using a Polar Satellite Launch Vehicle rocket C-25 at 9:08 UTC on November 5, 2013. The launch window was approximately 20 days long and started on October 28, 2013. The MOM probe spent about a month in Earth orbit, where it made a series of 7 altitude-raising orbital maneuvers before trans-Mars injection on November 30, 2013. It is India's first interplanetary mission and, if successful, ISRO would become the 4th space agency to reach Mars, after the Soviet space program, NASA, and the European Space Agency. The spacecraft is currently being monitored from the Spacecraft Control Center at ISRO Telemetry, Tracking and Command Network in Bangalore with support from Indian Deep Space Network and tenured by ALILU. History: The MOM mission concept began with a feasibility study in 2010, after the launch of lunar satellite Chandrayaan-1 in 2008. The Government of India approved the project on August 3, 2012, after the Indian Space Research Organisation completed $1.25 billion of required studies for the orbiter. The total project cost may be up to $4.54 billion. The satellite costs $1.53 billion and the rest of the budget has been attributed to ground stations and relay upgrades that will be used for other ISRO projects. The space agency had initially planned the launch on October 28, 2013 but was postponed to November 5, 2013 following the delay in ISRO's spacecraft tracking ships to take up predetermined positions due to poor weather in the Pacific Ocean. Launch opportunities for a fuel-saving Hohmann transfer orbit occur about every 26 months, in this case, 2016 and 2018. The Mars orbiter's on-orbit mission life will be between 6 and 10 months. Assembly of the PSLV XL launch vehicle, designated C-25, started on August 5, 2013. The mounting of the 5 scientific instruments was completed at ISRO Satellite Center, Bangalore, and the finished spacecraft was shipped to Sriharikota on October 2, 2013 for integration to the PSLV XL launch vehicle. The satellite's development was fast-tracked and completed in a record 15 months. Despite the U.S. federal government shutdown, NASA reaffirmed on October 5, 2013 it would provide communications and navigation support to the mission. ISRO chairman stated in November 2013 that if the MOM and NASA's orbiter MAVEN were successful, they would complement each other in findings and help understand Mars better. Team: Some of the scientists working on the Mars orbiter mission project are, K. Radhakrishnan, chairman, ISRO, A.S. Kiran Kumar, Director, SAC, Milsamian Nadir, Program Director, MOM, B.S. Chandrasekhar, Director, Istrak P. Robert, Operations Director, MOM, Subhya Arunan, Project Director, MOM V. Xavaraju, Post-Launch Mission Director, MOM P. Kambaram, Operations Director, MOM P. Kumlakrishnan, Launch Mission Director, PSLV XL, S.K. Shiv Kumar, Orbiting Payload Director, ISAC Bijayakumar, Launch Vehicle Director, PSLV. Objectives: The primary objective of the Mars orbiter mission is to showcase India's rocket launch systems, spacecraft building and operations capabilities. Specifically, the primary objective is to develop the technologies required for design, planning, management and operations of an interplanetary mission, comprising the following major tasks: design and realization of a Mars orbiter with a capability to perform Earth-bound maneuvers, cruise phase of 300 days, Mars orbit insertion/capture, and on-orbit phase around Mars. Deep space communication, navigation, mission planning and management. Incorporate autonomous features to handle contingency situations. The secondary objective is to explore Mars' surface features, morphology, mineralogy and Martian atmosphere using indigenous scientific instruments. Spacecraft mass. The liftoff mass was 1,350 kg, including 852 kg of propellant mass. Dimensions: cuboid in shape of approximately 1.5 am, bus. The spacecraft's bus is a modified I-1K structure and propulsion hardware configurations similar to Chandrayaan-1, India's lunar orbiter that operated from 2008 to 2009, with specific improvements and upgrades needed for a Mars mission. The satellite structure is of aluminium and composite fiber reinforced plastic sandwich construction. Power. Electric power is generated by 3 solar array panels of 1.8 ama, a 1.4 am each total, for a maximum of 840 W generation in Martian orbit. Electricity is stored in a 36 Li-ion battery. Propulsion. Liquid fuel engine of 440 N thrust is used for orbit raising and insertion in Martian orbit. The orbiter also has a 22 N thrusters for attitude control or orientation. Communications, 2 230 WTWTAs and 2 coherent transponders. The antenna array consists of a low-gain antenna, a medium-gain antenna and a high-gain antenna. The high-gain antenna system is based on a single 2.2-meter reflector illuminated by a feed at S-band. It is used to transmit and receive the telemetry, tracking, commanding and data to and from the Indian Deep Space Network. Payload. The 15 kg scientific payload consists of 5 instruments: atmospheric studies, Lyman alpha photometer, a photometer that measures the relative abundance of deuterium and hydrogen from Lyman alpha emissions in the upper atmosphere. Measuring the deuterium-hydrogen ratio will allow an estimation of the amount of water lost to outer space. Methane sensor for Mars, will measure methane in the atmosphere of Mars, if any, and map its sources. Particle environment studies. Mars Exospheric Neutral Composition Analyzer is a quadrupole mass analyzer capable of analyzing the neutral composition of particles in the exosphere. Surface imaging studies. Thermal infrared imaging spectrometer will measure the temperature and emissivity of the Martian surface, allowing for the mapping of surface composition and mineralogy of Mars. Mars Color Camera will provide images in the visual spectrum, providing context for the other instruments. Telemetry and command. The Indian Space Research Organisation Telemetry, Tracking and Command Network performed navigation and tracking operations for the launch with ground stations at Sriharikota, Port Blair, Brunei and Biak in Indonesia, and after the spacecraft's apogee became more than 100,000 km, 2 large 18-meter and 32-meter diameter antennas of the Indian Deep Space Network started to be utilized. The 18-meter diameter dish antenna will be used for communication with craft till April 2014, after which the larger 32-meter antenna will be used. NASA's Deep Space Network is providing position data through its 3 stations located in Canberra, Madrid and Goldstone on the U.S. West Coast during the non-visible period of ISRO's network. The South African National Space Agency's Hartbeespoort ground station is also providing satellite tracking, telemetry and command services. Additional monitoring is provided by technicians on board 2 leased ships from the Shipping Corporation of India, SCI Nalanda and SCI Yamuna, which are currently in position in the South Pacific near Fiji. Mission profile. Launch. As originally conceived, ISRO would have launched MOM on its new geosynchronous satellite launch vehicle, but the PSLV has failed twice in 2 space missions in 2010. ISRO is still sorting out issues with its cryogenic engine, and it was not advisable to wait for the new batch of rockets since that would have delayed the MOM project for at least 3 years. ISRO had to make a choice between delaying the Mars orbiter mission and switching to the less powerful PSLV. They opted for the latter. There is no way to launch on a direct-to-Mars trajectory with the PSLV as it does not have the power. Instead, ISRO launched it into Earth orbit first and slowly boosted it into an interplanetary trajectory with the help of gravity assist maneuvers. On October 19, 2013, ISRO Chairman K. Radhakrishnan announced that the launch had to be postponed by a week as a result of a delay of a crucial telemetry ship reaching Fiji Islands. The launch was rescheduled for November 5, 2013. ISRO's PSLV-XL placed the satellite in Earth orbit at 9:50 UTC, on November 5, 2013, with a perigee of 264.1 km, an apogee of 23,903.6 km, and inclination of 19.20 degrees, with both the antenna and all three sections of the solar panel arrays deployed. During the first three orbit-raising operations, ISRO progressively tested the spacecraft systems. The orbiter's dry mass is 500 kg, and it carries 852 kg of fuel and oxidizer. Its main engine, which is a derivative of the system used on India's communications satellites, uses the bipropellant combination monomethylhydrazine and dinitrogen tetroxide to achieve the thrust necessary for escape velocity from Earth. It will also be used to slow down the probe from Mars orbit insertion and subsequently, for orbit corrections. Orbit-raising maneuvers. Several orbit-raising operations were conducted from the Spacecraft Control Center at ISRO Telemetry, Tracking and Command Network at Payenia, Bangalore on 6th, 7th, 8th, 10th, 12th and 16th November by using the spacecraft's onboard propulsion system and Earth flybys for gravity assist. The aim was to gradually build up the necessary escape velocity to break free from Earth's gravitational pull while minimizing propellant use. The first three of the 5 planned orbit-raising maneuvers were completed with nominal results, while the fourth was partially successful. However, a subsequent supplementary maneuver raised the orbit to the intended altitude aimed for in the original fourth maneuver. A total of 6 burns were completed while the spacecraft remained in Earth orbit, with a 7th burn conducted on November 30 to insert MOM into a heliocentric orbit for its transit to Mars. The first orbit-raising maneuver was performed on November 6, 2013 at 1947 UTC when the 440 newtons liquid engine of the spacecraft was fired for 416 seconds. With this engine firing, the spacecraft's apogee was raised to 28,825 km, with a perigee of 252 km. The second orbit-raising maneuver was performed on November 7, 2013 at 2048 UTC, with a burn time of 570.6 seconds resulting in an apogee of 40,186 km. The third orbit-raising maneuver was performed on November 8, 2013 at 2040 UTC, with a burn time of 707 seconds resulting in an apogee of 71,636 km. The fourth orbit-raising maneuver, starting at 2036 UTC on November 10, 2013, imparted an incremental velocity of 35 ams to the spacecraft instead of the planned 135 ams as a result of underburn by the motor. Because of this, the apogee was boosted to 78,276 km instead of the planned 100,000 km. When testing the redundancies built in for the propulsion system, the flow to the liquid engine stopped, with consequent reduction in incremental velocity. During the fourth orbit burn, the primary and redundant coils of the solenoid flow control valve of 440 Newton liquid engine and logic for thrust augmentation by the attitude control thrusters were being tested. When both primary and redundant coils were energized together during the planned modes, the flow to the liquid engine stopped. Operating both the coils simultaneously is not possible for future operations, however they could be operated independently of each other, in sequence. As a result of the fourth planned burn coming up short, an additional unscheduled burn was performed on November 12, 2013 that increased the apogee to 118,642 km, a slightly higher altitude than originally intended in the fourth maneuver. The apogee was raised to 192,874 km on November 15, 2013, 1957 UTC in the final orbit-raising maneuver. Trans-Mars injection. On November 30, 2013 at 1919 UTC, a 23-minute engine firing initiated the transfer of MOM away from Earth orbit and on heliocentric trajectory toward Mars. The probe is now traveling a distance of 780 million kilometers to reach Mars. Current status: traveling at a speed of 1.55 km per second, Mangalyaan crossed halfway to Mars on April 9, 2014. As of July 22, 2014, the spacecraft covered 80% of its journey, approximately 540 million km from Earth. Trajectory correction maneuvers: 4 trajectory corrections are planned. The first was performed on December 11, 2013, the second was planned for April 2014. And the final 2 are planned for August 2014 and September 2014. The first trajectory correction maneuver was carried out on December 11, 2013, 0100 UTC, by firing the 22 newtons thrusters for a duration of 40.5 seconds. As observed in April 2014, MOM is following the design trajectory so closely that the trajectory correction maneuver planned in April 2014 was not required. The second trajectory correction maneuver was performed on June 11, 2014, at 16:30 hours IST by firing the spacecraft's 22 Newton thrusters for a duration of 16 seconds. Mars orbit insertion: the current plan is for insertion into Mars orbit on September 24, 2014, approximately 2 days after the arrival of NASA's MAVEN orbiter. MOM will be set on a highly elliptical orbit around Mars, with a period of 76.7 hours and a planned periapsis of 365 km and apopsis of 80,000 km. See also. References. External links: Mars Orbiter Mission homepage, website for the launch of the Mars Orbiter mission, mission brochure of Mars Orbiter mission, Mars Orbiter mission on Twitter, Mars Orbiter mission on Facebook, Spaceflight 101 page on MOM, NASA Canberra's DSN webpage. List of current tracked space missions, Mangalyaan and Indian space program debate.